Hey guys, this is Unit 10 for our final exam review for Precalc. This is made in 2018 for the 2019 school year. In the 2018-2019 school year, I guess it's currently 2019. The first thing I want you guys to recognize is that on number 7, that this shouldn't have said f of x. This should actually just be the limit. So this should be the limit as x approaches 2 of all of this. Well, let's just jump right in. The first thing I like to do with limits is find all the ones that have infinity. So you'll notice I have infinity, 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 infinity. So that's my end behavior rule. So I'm just looking at degree. So in this one, I'll notice that I'm bottom heavy because I have x cubed. So this is going to be does not exist. Here it's top heavy. Oh, I'm sorry, guys. I've already messed up on you. Pardon me. This was bottom heavy, so this has an answer of 0. See, Mrs. Barnes makes mistakes too. This is top heavy, and so this is going to be does not exist. Okay, if I look over here, this is going to be bottom heavy as well. These have the same degree, so I take my leading coefficients of 3 over 1. Okay. We also learned some trig limits. You notice these both are sine of this is sine of 3x, this is sine of 5x, and we said our trick for this is just going to be 3 over 5. We just take the coefficient over the coefficient of the x terms. Okay, this is tricky. If I were to plug in 0, I'd get 2 over 0. We can't divide by 0 and get a numerical answer. It's undefined. So if I divide by 0, that's when I start looking at my tricks. Like, can I factor? Can I rationalize? Can I use trig limits? And the reality is we don't have any tricks to help us with this. If we're still stuck after trying any tricks that we can do, then the answer is just going to be does not exist because I'm dividing by 0. If I were to actually draw a picture of this graph, it would look something like this. So you'll notice that the limit from the right for 0 is infinity. The limit from the left is negative infinity, so it makes sense that the limit doesn't exist. For number 7, if I plug in 2, I'll get 0 over 0. So I'm going to factor. And you'll notice I have a common factor here and here. So now I can plug in 2. That's going to give me 2 plus 2 over 2, which is 4 over 2. That has a value of 2. Okay, again, let's try plugging in 4. That's going to give me 16 plus 4, so 20 minus 20 over 0. So that's going to be no good. So I'm going to factor. My numerator is going to be x minus 4 and x plus 5. Those are two numbers that multiply to negative 20 but add to a positive 1. And I have a common factor, so now I can plug in my 2. Remember, my limit notation has to stay while I have x's, but as soon as I plug in 2 in this case for x, I can get rid of it. So in this case, I finally plugged in 2. So there's no more limit notation. Okay. The last type is going to be rationalizing. If I plug in 0, I'm going to get 4 minus the square root of 16, so 4 minus 4 over 0. 0 over 0 is no good, so I'm going to use my process of rationalizing. It lets me deal with radicals, or it lets me deal with limits that have radicals that give us 0 over 0. Okay. So remember, I'm only going to FOIL and factor out in my numerator because that's the one I did this process for. And when I do that, I'm going to get 4 times 4, which is 16. When I multiply these terms and these terms together, I'm going to get a positive 4 times root 16 minus x and a negative 4 root 16 minus x. Those are going to cancel out. So I did these, and now I'm left with these terms. That's going to be negative. And when I multiply things together that had the same thing that have a radical, the radical is going to go away. And then remember, I'm not going to FOIL through in my denominator. Okay, this negative needs to distribute. So this is going to become a negative 16 and a positive x. So if I have a 16 minus 16, those will cancel out. All I have left in the numerator is an x, so those x's are going to cancel out. And when I do that, I have a 1 left over in my numerator because anything divided by itself is 1. I'm going to plug in 0 now. I'm going to get 1 over 4 plus the square root of 16 minus 0. That's 1 over 4 plus 4, which is equal to 1/8. So the next thing we did a lot of is limits from graphs. So the first thing it actually asks us for a function value. So if I go to 1, I'm looking for the filled in dot. And the filled in dot has a y value of 2. If I do the limit as I approach 1 from the left, I'm coming in from the left and I approach a y value of -1. But if I come in from the right, I approach a y value of 0. Well, if my left and my right limits don't match, notice that from the left I approach -1, from the right I approach 0. If those arrows don't point directly at each other, the two-sided limit does not exist. So just look at a couple other places. At 0, you'll notice I come in from the left, I have a value of 2. As I come in from the right, I have a value of 2. So the limit does exist because both sides are approaching a value of 2. For 3, as I approach from the left, I have a value of 0. As I approach from the right, I have a value of 1. Since those don't meet, the value of this two-sided limit does not exist. The last thing we spent a lot of time on in this unit was continuity, so let me go through these two problems real fast. Make it so this doesn't show up as bad. Okay, so when I deal with continuity, I have 3 steps. Step 1 is to figure out if the function is defined at the point I care about. Step 2 is to see if the limit exists. And then I'm going to use real shorthander. I want to just figure out if the function value and the limit are equal, or steps 1 and 2 equal. So let's jump right in. The first thing I need to do is figure out what the function value is at 0, because 0 is where I'm figuring out if it's continuous. Well, notice that the equal sign is here. So this is when x is 0. So I'm going to use this top piece. Plug in 0 for x, and I get 1. So my function's defined. I have a numerical value. Now I need to do my limit. Well, here's where it gets a little tricky. When x is greater than 0, I use this. When x is less than 0, I use this. That means we're switching between these at 0, which is the value we care about. So the before and the after are different. If the before and after are different, I have to use a limit from the left, and I have to do a limit from the right. Well, this is when x is smaller than 0, so this is the before. This is when x is larger than or equal to 0, so this is the after. So if I plug in, oopsies, sometimes my hands and my brain don't do the same thing when I'm talking. Okay, so if I plug in 0, I'm going to get 0 minus 1. If I plug in 0, I'm going to get 0 plus 1. So you'll notice the limit from the left and the limit from the right are not the same. So my process is broken down, so I stop now, and I say f of x is not continuous at x equals 0 because the limit, as I approach 0 in my function, did not exist. If the limit doesn't exist, that was step 2, my function can't be continuous. All 3 of these things have to be true in order for it to be continuous. So let's try number 17 now. I'm still going to start with figuring out if my function's defined. We're figuring out if it's continuous at 1. And notice it says this is what's happening when x is 1. So I'm going to use this, and plug in 1, and I get 0. Step 2 is my limit. Okay, this is what's happening when x isn't 1. So this is the before one and the after one. So I can just do one limit to figure out what's happening around the x value of 1. Well, if I were to plug in 1 into this, I get 0 over 0. So I'm going to factor. And when I do that, I'm left with just x plus 1. And when I plug in 1, I get 1 plus 1, which is 2. So my limit did exist. I got a value, and the value is 2. So step 3 says, are the values from step 1 and step 2 equal? Whether or not this was 0, this was 2. So I'm going to say f of x is not continuous at x equals 1. That's a funny at sign. Because the function value at 1 was not equal to the limit as x approaches 1 of my function. So guys, that's the Unit 10 review. The big things to look at is making sure you can evaluate the different types of limit problems. So can you factor if you need to? Can you rationalize? Can you use the trig limits? The trig limits shouldn't be super complex if you see them. And then the other big thing is continuity and also with limits on a graph. So make sure you guys know these 3 steps. You might have to do it out at least one full time for your response. So make sure you're ready for that. Okay.